Good afternoon, this is Mr. Schweitzer, and looking at a little video here on how to deal with significant figures when you're multiplying and dividing. When in any mathematical process you're running, you also always want to be aware that your least accurate value will control the accuracy. So, for example, if you have a very precise number, let's say you have measured with a very sophisticated graduated cylinder, and this particular value here is, at 50.05 milliliters, and you want to multiply this value or divide this value by some other entity. Okay, let's say I multiply this thing. Okay, well, this is volume, and of course we could do a division here on the fly. So density is equal to mass divided by volume. Okay, so this is division. It's a perfectly good mathematical calculation. So let's say this thing has 50.05 milliliters of volume. So I want to do my calculation in grams per milliliter. Alright, so let's take our water out. You dump it in, or you say you dump it into a tray, or you zero it out, and you put this water onto a scale. And now this particular scale could be a nice fancy scale, or maybe it's a triple beam balance scale, which says, okay, this thing has a value of only 50 grams. And let's say this thing isn't very accurate, only gives two numbers. Now, on an electronic scale, whatever's listed there would be significant. So it's got two significant digits. And I would take, okay, 50 with two significant digits, that's my grams, and divide it by 50.05. Now, because this number only has two sig figs and this number has 4, all this nice little measurement here gets washed away. I want my answer to have only two significant figures. So my rules here, just kind of review the rules a little bit here. First thing you want to do is, whenever you're doing anything mathematical, is assign number of sig figs. Step 2, very simple, simply calculate, which is where we are right now. I have 2 sig figs and 4 sig figs. I'm going to divide them, and this number is going to be ever so slightly less than 1. 50 divided by 50.05, and I get 0.99999, and it just keeps on going. I should say there's a couple zeros in there actually. There's 3 9s, 3 zeros, and 3 9s, so I'll just redraw that. 0.999000999. I imagine that probably continues on and on and on. But either way, at this point, I would like to round, okay, this to the correct number of significant digits. To correct number of sig figs. Now, in this case, the correct number of sig figs is matching the smallest one, which in this case is 2. I would cut it off right here. This 9 rounds this 9 up, and I'm going to get a density of 1.00 sig figs. Now, actually, this is even going to give me even less. It's going to be 1.0 sig figs. This is 2 sig figs. This is my answer. Now, the density is looking like it may even be less than 1, but because of the inaccuracy of the mass, then I am going to get a number that is essentially 1. I could get a number that increased the accuracy of this number, and eventually I could get the sig figs under that of 1. or get the value under 1, under 0.9999. Okay? Now again, this is the general idea. I got a nice little example there of using an actual division calculation, but let's try a couple of examples. Let's say I have 25 divided by, let's say, 3. Okay, now in this case, for the rules that I have talked about here, okay, let's go 3.0. So I have the 25 assigned number of sig figs. There's no decimal. As I mentioned in an earlier video, I'm going to call this infinite number of sig figs. No decimal, it's an exact value, exactly 25. We're dividing 25 eggs amongst 3 people. I shouldn't even say 3 people, because this is not an exact value. 25 divided by 3 measured values. This has 2 sig figs. So my answer has to have 2 sig figs. So now it's done. Calculate. Plug it into your calculator. 25 divided by 3 equals 8.333333. Keeps on going. But I want to cut this number off at 2 sig figs. So the 3 is not big enough to round up, and I get 8.3 is my answer. Okay. An actual multiplication example. We could say, okay, I have 25.000 times 4.0. Alright, I have 2 sig figs and I have 5 sig figs. This is going to give me, don't forget your value, your answer is 100. Okay, the question is, how many numbers do I use? Alright, well, 100, and I want this thing to have 2 sig figs. So at this point, if I leave it like this, I'm only indicating 1 because of our rules on this could be an estimate. So I'd want to list this thing as 1.0 e to the second would be really probably the best way. Or you could go 100 decimal, the line over the 1 and the 0. So I got a couple of decent examples here showing you how different things work amongst multiplication and division. Stick around for a couple of eventually some practice problems on determining sig figs and adding and multiplying them. Thank you.